This video will cover the odd problems on pages 4.7 and 4.8 in our notes, and then there will be another video with the even problem. So the notes before this talked about proportional relationships. So we looked at a big list, a big table, to see whether or not those numbers were proportional. And what that meant was when we divided them out, they had the same rate. Well, when we talk about an actual proportion, it's an equation that states that two ratios are equal. So when we solve proportions and when we determine whether they are a proportion, we do something called their cross product. So this right here, A over B equals C over D. That is what a proportion is. That's your equation that states that two ratios, remember ratios can be written as fractions, are equal. So that first fraction equals the second fraction. When you do the cross product, you have to do the two that are diagonal from each other. So you do the top of one and the bottom of the other one, and you multiply them. So A times D is equal to, and then the other ones, B times C. Now, it does not always have to be in that order. You don't always have to start with the top left. It's just easier because that's the first number you normally notice. But you multiply the two that are diagonal, and then you multiply the other two that are diagonal, and don't forget to put an equal sign between them. So your first job is to check to see whether the two they give you are equal or not. There are a couple of different ways you could do this. You actually can just do 5 divided by 6 and get that decimal, and then 20 divided by 24 and get that decimal to see if they are the same. So that's one way to do it. The way this tells you is to use their cross product. So that's what I'm going to show you. But if you want to actually divide them out to see if their decimals are the same, that's fine too. I just want to practice our cross product. So we're checking 5 times 24. Does that equal, that's what we're checking, 6 times 20. Now you don't actually have to write that out every time. I just want you to see where it's coming from. So 5 times 24 gives me 120. 6 times 20 also gives me 120. So this would be yes, those two are equal. All right, so this one I'm not going to write out. I'm just going to do 9 times 42 is 378. And then 7 times 54 is also 378. So that's another yes. All right, so you need to multiply two that are diagonal from each other and then multiply the other two that you haven't used yet. And then that is your two numbers. If they're equal, then yes, it's a proportion. If they're not equal, then no. So number 5, 15 times 56 gives us 840, and then 20 times 42 also gives us 840. So that would be yes. Number 7, 0.5 times 40 would give me 20. We want to know, does that equal 18 times 1.5 gives me 27. So those are not equal. So no, they do not form a proportion. All right, so it's going to give you two fractions. There are two ways you can decide if they're equal. You can go ahead and divide them each individually to get their decimals, to see if their decimals are equal. Or you can do what I did here and do the cross product. Sometimes multiplication is just a little bit easier, so you can do it that way. Now, solving the proportion is the big thing we need to do here. All right, now I'm going to show you kind of two different ways to do this. The first thing you could do is you could actually simplify 16 over 12. All right, you don't need to, but you could. I'm not, just because that takes an extra step. If you follow, I'm going to actually write this over here again. A over B equals C over D. So then A times D equals B times C. So you're going to start with the proportion, the two fractions equal to each other, and then this will be your first step, the cross product. All right, so I'm going to do it in that exact order, but then I'll tell you on the next one, I would actually do it differently. Okay, so if I do it in that order, I'm going to take 16 times 3 equals, most people forget to put the equals between the two, 12 times x. All right, now you do not have to write that first step out. If you are comfortable just doing the multiplication all at once, you can go ahead and do that. So 16 times 3 gives me 48 equals 12 times x. We just write that as 12x. So then you need to get the x by itself. It's being multiplied by 12, so we need to divide by 12 to get that to go away. Divide by 12, x equals 4. All right, now it says to check your solution. So to check, you're going to do 16 over 12 equals 4 over 3. You can do what we did above. 16 times 3 is 48, and 12 times 4 is 48, so we did that correctly. Or again, you could also divide the two to make sure their decimals are the same, and they would be. All right, now, if you remember, I don't like to have my variables on the right-hand side. So what I do when I solve proportions is I find my variable first. So I'm actually going to do these two first. So it doesn't matter if you do A and C or B and D or however you want to, what order you want to do those in. All right, you just have to make sure you pick two that are diagonal from each other. So W times 5, we would write that as 5W equals 26 times 6 gives me 156. All right, so I did not write out all of my steps. If you still need to write out W times 5 equals 26 times 6 and then get to this step, that's totally fine. All right, I'm just trying to make it as few steps as possible for you. So if you can just remember to multiply, then you don't have to write that step out if you don't want to. Anyway, we need to divide by 5 now to get W by itself. This one is going to be a fraction, so it is okay, or a decimal. It is okay to get decimals for these. You're going to get 31.2. Okay, so then again, if you want to check, you're just going to rewrite it. 26 over 31.2 equals 5 over 6. So then multiply 26 times 6 gives me 156. 31.2 times 5 also gives me 156. So we know it works. For number 13, I see that my n is up here, so I'm going to do n times 30, or 30n. So always just put the number first and then the letter, equals 6 times 19, which is 114. All right, so again, multiply the ones that are diagonal, set them equal to each other. Then we need to divide by 30 in this case to get the n by itself. So 114 divided by 30 gives me 3.8. So again, I'm not going to write it out, but if you want to check, you put the 3.8 over 6. You can cross multiply again, or you can divide them out to make sure it's the same decimal. So there's your answer for that one. For 15, I find my p down here. So 20 times p is 20p equals 32.5 times 8 gives me 260. All right, then I need to divide by 20 to get p equals 13. And 17, this one's a little bit trickier. We have 4x times 15. So you need to do 4 times 15, which is 60, and then the x goes with it. So multiply the numbers together, and then make sure you put the x along with it. 60x equals 5 times 84, which is 420. Then we divide by 60, and x equals 7. So this one's a little bit trickier to check. If you're going to check it, you need to do 4 times 7 is 28 over 5. Does that equal 84 over 15? Okay, so again, you could divide them both to get their decimals, or you can cross multiply and see that yes, they are equal to each other. All right, we are not going to do these bottom ones, so you don't have to worry about those.